The last part of 5.2 that we're going to work through is the intercepts of our graph. And for our linear functions, they always have two intercepts as long as it's not a horizontal line. The intercepts are the x-intercept and the y-intercept. And now for these intercepts, the x-intercept, that's the spot where it crosses the x-axis. And for an x-intercept, the y-coordinate of that point is always 0. So when we want to find the x-intercept, the y-coordinate is 0, so we can just replace 0 in our equation, replace y in our equation with 0, and then solve, and that gives us the x-intercept. The y-intercept of our graph is where it crosses the y-axis, and for that, the x-coordinate of that point of where it crosses the y-axis is also always 0. So if I want to find the y-intercept, I can replace x with 0, and that will tell me my y-intercept. So whenever you want to find an intercept, let the other variable in the equation be 0, and when you solve, you'll be solving for the variable that you want to find the intercept for. So now this example here, we have been given the coordinates of 2 points as being 0, -4, and 5, 0. And I want to know which one is the x-intercept and which one's the y-intercept. So the first one, we have 0, -4, which means that 0 is in the x position of this ordered pair, which tells us that this is the y-intercept. And then our second ordered pair, 5, 0, the 0 is in the y position, so this is the x-intercept. So now, let's work through a problem to actually find our intercepts. We have been given the linear equation p equal to -5x plus 240. And I want to find the x and p intercepts. I'm going to start off with finding the p-intercept because that one is usually a little bit easier, whatever variable we're using for y. And that means I am going to replace x in the equation with 0. So we're going to have p equal to -5 times 0 plus 240. And -5 times 0 is just 0, so this leaves us with 240. So this means our ordered pair, well, we put in 0 for x, and we got back 240. So we have 0, 240. The next one, for the x-intercept, I want to replace p with 0 and solve this for x. So we have 0 equal to -5x plus 240. And now I have -5x, so I'm just going to add 5x to the other side to deal with that negative, so I don't have negatives anymore. So this is going to give us 5x is equal to 240. And now we can just divide both sides of our equation by 5. So that gives us that x is equal to 240 divided by 5, which is 48. So now our ordered pair for the x-intercept, well, we got back 48 for x when we put in 0 for p. So the ordered pair is 48, 0. Okay. And then lastly, let's work through a word problem with finding intercepts. That way we can then explain what they mean in the context of an application. So this problem, we have been told that the number of African elephants has been decreasing, and in 1950 there were approximately 5 million elephants, and 5 million is the same thing as 5,000 thousands of elephants. And now the model that we have been given, or the model for the number of elephants, is given to us here as being n of t equal to 5,000 minus 67.43 t. And in this case, it's given to us in function notation, where we have the n of t part of this, instead of using a variable like y. So our first one is to find our n-intercept and explain what it means. So n-intercept means I want to replace t in my equation with 0. So we want to evaluate n of 0, and that's going to give us 5,000 minus 67.43 times 0, which now that's just going to be 5,000. So our ordered pair is 0, 5,000. But now what does this mean? This 0 is representing years, and this 5,000 is our number of elephants in the thousands. So 0, that is corresponding to our year 1950, the start of this model. So in year 0, aka 1950 in real life, there were 5,000 elephants. The next one, we want to find the t-intercept. So that means we want to replace n of t, our output variable here, with 0, and then we need to solve for t. So we are going to have 0 equal to 5,000 minus 67.43 t. So now to solve this for t, I'm going to add the 67.43 t to both sides. So that gives us 67.43 t equal to 5,000. And now we can divide both sides of our equation by 67.43. So this gives us that t is equal to 5,000 divided by 67.43, which is approximately 74.15. So now our ordered pair for this is going to be 74.15 for t when we put in 0 for our n of t. And now let's explain what this means. We got 74.15, so in year 74.15, which in real life, that's going to be the year 1950 plus 74, so approximately 2024. There will be 0 elephants according to this model. So hopefully they made changes and this is not, they're not going extinct anymore, but according to this model that we had been given, that would be what would happen with this.